So, good evening. My name is Opawale Mujibolajide, and this is the video explanation to question number one of E301 Microelectronic Devices and Circuits. Okay, moving on to the 1A. Inside the question, we were given the intrinsic concentration of the material. It is given to be this. It is given, which is given to be this equation here. Ni equals to At to the power 3 over 2 exponential minus Eg all over 2 kBt. So we are given the question that using the band gap of silicon and gallium arsenide, we should plot the variation of intrinsic carrier concentration versus 1000 over temperature in degrees Celsius. Hence, otherwise, determine the concentration of phosphorus that will be sufficient to make gallium arsenide extrinsic at 700 degrees Celsius. So moving on, we know that the band gap of silicon is 1.12 electron volt, while that one for gallium arsenide is 1.42. And we know our Boltzmann constant is 8.62 to the power of 10, 8.62 times 10 to the power of negative 5. And as you already know from our early class that the carrier concentration for silicon, the intrinsic carrier concentration for silicon at 300 degree Kelvin, which is the room temperature, is 10 to the power of 10. So when we input that one inside the equation, we're able to get A, which is the constant, to be 4.89 times 10 raised to power 15. So with that, we're able to get equation for the intrinsic concentration of silicon and the one for gallium arsenide. So now moving on to the plotation of graph, where we start we start our temperature from 200 degrees Celsius to 1000 degrees Celsius. So at 200 degrees Celsius, which is 473 Kelvin, we inputted that into our earlier equation of carrier concentration for silicon and gallium arsenide, which we got to be 5.45 to the power of 10 raised to power 13, then 1.38 times 10 to the power 12. And we did for 400 degrees Celsius, we got this one and this. And the same thing for 600 degrees Celsius, we got this, this, and this. And lastly, at 1000 degrees Celsius, which is 1273 Kelvin, we have 1.35 times 10 raised to the power of 18, then 3.44 exponential to the power of 17. So for us to be able to plot the graph, we have to make a table for our variables. We have a column for temperature. We have a row for temperature, which is at degrees Celsius. Then we have silicon concentration for silicon, the intrinsic concentration of gallium arsenide, while this is 1000 to the power 1000 over T. So our graph for that, it says we should make a graph of the intrinsic carrier concentration, which is on the y axis, then against the carrier against 1000 over 7. And from this table, we know that 1000 over 7, the highest is 5, while the lowest is 1. So for our graph on the x-axis, we make 10 centimeter to equals to 1 unit. And on the y-axis, we know that we are plotting against our concentration of silicon and intrinsic concentration of gallium arsenide, which is on the y-axis as we see. So on plotting the graph, we saw that this is a decaying exponential for gallium arsenide and a decay exponential for silicon for the intrinsic concentration of silicon. So that is that. Okay. And the second question, the 1A, states that we should find the concentration of phosphorus that is sufficient to make gallium arsenide extrinsic at 700. They said we should find the concentration of gallium arsenide at 700 degrees Celsius, which is at 973 Kelvin.